Now we will continue with our discussion on the other considerations related to LLM ops in production. So one of the most consequential decisions that you will take with respect to running LLMs in production is related to infrastructure, because that directly impacts performance, and as we will see later as well, it actually impacts cost in a significant way. So before we get to what the options are, excuse me, it's important to understand what is the problem statement that you're dealing with. So the LLM that you're trying to use for inference as part of an application, embedded as part of an application, you should really look at where is that usage happening and what is the nature of that usage. So these are two very important questions. So the where part of the question corresponds to where is that end application running, and is the end application itself running as a whole, or is split across multiple different boundaries. What are the boundaries? One would be a local boundary meaning it's running local to a machine only without any external access, or it's running on an edge boundary, which means it's running on an edge device which is connected to the internet, like a mobile phone or a laptop, etc. Or it could be a hosted boundary, which means it's hosted by a third party, not necessarily by you. It could be by a vendor, could be by um, like a mainstream popular provider like OpenAI, or it's a co-located boundary, which means it's running in a cloud or a data center where the rest of your servers are also running, right? So you've got to really understand what is the nature of the usage of the LLM, but more importantly, the application itself, right? Because the LLM is not standalone, like we have spoken multiple times. It's part and parcel of a business process. So keep that in mind. You should look at all of that. That influences the infrastructure decision. The second is the nature of the usage, and this is obvious, right? The more you know real time an LLM response needs to be, the lesser the latency is that you're expecting from it, which means the nature of the instructions, the nature of the tasks that it's trying to do, and the infrastructure that it's required for serving that LLM will need to change appropriately. So the example here would be um, an LLM that's used for reasoning on a piece of information can definitely take a few seconds to think through the response, come back with the reason. Whereas the LLM that's responsible for real time speech translation has a completely different latency profile, right? Because the embedding of that particular real time translation capability will critically drive a speech application or a video recording application or a meeting application where two people are trying to meet across different languages and zones. So the criticality or the nature of the usage will be determining the uh, parameters associated with infrastructure choice, which is concurrency as well as latency. The third consideration, which also drives the infrastructure choice, is whether you're comfortable um, having a third party host the LLM entirely by themselves. Like, for instance, OpenAI giving you GPT-4 Turbo as an API, or you are comfortable only um, with taking that entire model, but you cannot consume an API from outside, which is basically the LLM itself, which is a large language model itself. Or are you not comfortable with any of those approaches and you need to really own the entire solution, right? This also plays a critical role on the infrastructure choice as well as the performance. So public cloud, like the ones we have used with Google Cloud right now, and also the case with other major cloud providers, they offer a myriad of machine learning deployment options, including for LLMs. One of the most popular ones is something called as Model Garden. We saw this in week 10 hands-on portion. It provides a variety of different types of models, both foundation models as well as task-specific fine-tuned models, and these are available for you to directly use. The catch is you cannot really download them as you would like, for instance, download from a GitHub repo, right? These model gardens are not meant for broad dissemination of the code base. They are meant for you to go from code or weights to a running model very quickly, right? So they want you to continue to use them, their resources, their in this case Vertex AI, Workbench instances, etc. Right? So it's a walled garden. It's a model garden, all right. It's also a walled garden. Um, the second aspect that the public cloud platforms also provide are, you know, out of the box models for very specific tasks. Like for instance, if you go to Amazon has something called as recognition, which is extremely good at character recognition, image recognition, out of the box for most cases. In which case, you may not need to build a fine-tuned model at all. But the catch again is you have to pay Amazon for every time you use that recognition API. You may not be, in fact, configuring any virtual machines or endpoints or anything else either. So it's serverless from that perspective, nearly. But you've got to pay for every serving that you do from that particular API. And therefore, the costs add up. And OpenAI is a great example, right? The tokens that you send to OpenAI and the tokens that it responds back with the output, those tokens quickly add up in terms of cost. So you've got very little control on the cost if the context window just keeps on increasing. So that's also part for the course, right? When you start using these hosted API models. And last but not the least, with the latest of innovations available in the space, frameworks are available. Like for instance, the agentic frameworks that are part of Vertex AI's, Vertex AI's tab. You can take a look at it as part of the, exploration of the Google Cloud Console. And those are also very useful for you to get started with, right? So you don't have to go and install libraries by your hand. You can actually use some of this natively. But it all comes with a associated rider on cost and performance. So let's take a look at this third party versus self-hosted dilemma. Most companies go through this, right? And the reason for that is the most important reason is data security. So if you look at any regulated industry, the data security and privacy concerns are paramount, right? So much so that it practically dictates what kind of tooling, what kind of AI models you have available at your disposal. So if you are coming from a regulated industry which says that I cannot share my data with a model that's hosted outside my country, then you're absolutely, have no way to use, third-party hosted models anymore, because you have no control on where the third-party hosted model is available or running. Uh, it may not run in your country at all. So if you take a look at OpenAI as an example, OpenAI provides GPT-4 or GPT class of models as APIs. You can sign up for that. By default, those API models are running on the OpenAI cloud. And the OpenAI cloud itself is running in the US predominantly. Let's say you belong to a country which has regulations attached to it that says that data, especially customer data, cannot leave the country's shores. What do you do then? You cannot really use the OpenAI hosted models anymore. But there is a way around it. OpenAI has done a partnership with Azure, Microsoft Azure, and you can run OpenAI's models deployed within the Azure region if the Azure region is available in your country. So that's a workaround, right? Which converts that third-party hosted API into a model that's deployable into a locally hosted API running in the local region. It can still be managed by a vendor, or it can be managed by you. That's a separate consideration. But at least there are workarounds available like this. Now, naturally, if you choose a completely open source model, let's say for instance Llama 4, then there is no restriction per se, right? You go to the model garden in Google Cloud, you deploy that into the local region, not the US central one that we did in week 10. Just go deploy it in the local region and you're done, right? You've now got the guarantee that the data is not going to escape your shores. So that's data security and privacy, main consideration for most companies. The second main consideration is something called as vendor lock-in. So this might be new to some of you, But when you start using vendor software, like software from a particular vendor, like for instance the GPT-4 from OpenAI, over a period of time, your application code is no longer generic enough. It starts to look very specific to OpenAI's syntax and OpenAI's APIs, etc. So much so that the skill level in your company starts to become more tuned towards OpenAI's knowledge base. Let's say some time passes by, and then for whatever reason you now want to change that to Gemini. The language changes, the interfaces change, and we saw how prompts and models go very close hand in hand, and prompt is code. So which means there's a significant amount of engineering effort required to change your application to work on Gemini, and that significant amount of effort requires skill set, requires knowledge of what's happened before, right, and also appropriate price points and costs attached to it. So this is what is called as vendor lock-in, and this might create a friction such that the transition to some other technology or some other vendor is increasingly prohibitive with the more costs or the more investments that go into the current vendor. So that's also a consideration between third party versus self-hosted. In self-hosted, there is no vendor lock-in because it's obviously hosted by you and it's managed by you. By the way, there is a third option in between as well, right? Which means it's hosted by you but managed by somebody else. There also there is some bit of vendor lock-in because the skill set associated with managing that particular technology resides with somebody outside the company. So something to keep in mind as a consideration. The third, consideration is predictability of behavior. And here I'll take an example in a slide later on of what I mean by this. In essence, it means that if a third party is hosting your AI API or LLMs, you don't have the guarantee that it's going to be predictable in behavior. It's going to produce the same consistent output for the same input again and again. So that's predictability. And last is the cost performance trade-off. If for whatever reason you find that the third party hosted API is giving you the right accuracy, but it's not giving it fast enough, you may not have an option to change that, right? You may not have an option to make it faster because the hosted API is coming with a limited form factor or a boundary around what it can do that prevents you from increasing performance, even if you were willing to pay more money. Alternatively, you might actually find that you need better performance and you might sign up for cost which is prohibitive and you may not know about it, right? So that's also another part of the problem. So these four factors dictate what kind of infrastructure that you'll have to invest in, whether it's self-hosted or third party or somewhere in between. So let's take a look at that unpredictable behavior with a case study, and this one is from OpenAI itself. So when GPT-4 was released, and this was back in 2023, there were multiple versions released, obviously, during the year. But one of the interesting things that somebody or a researcher, Liu et al., what they found was that the performance of GPT-4 degraded for certain tasks as newer versions of GPT-4 got released, which is quite remarkable, right? And also, it was at that point extremely concerning for anybody who was dependent on OpenAI for their downstream software. So remember, this is 2023, and that was peak boom time for the excitement around GPT-based architectures, and especially OpenAI had the lead at that time. So everybody was gravitating towards using OpenAI, and OpenAI's ChatGPT became I think, the most downloaded tool in the Apple Store or whatever. By far, it eclipsed the next best by orders of magnitude. So the popularity was huge, and then suddenly to be hit with this kind of a regression in behavior was astounding, right? It suddenly brought the entire wheel to the ground, so to speak, right? And that was a wake up call for the industry. And at that time, when the researcher actually published this open paper, how on documenting that degradation in behavior so that everybody else can reproduce it, they found three very specific tasks where the degradation was significant, right? One was a test for prime numbers. It's a mathematical test. The GPT-4 version released in March 2023 that year got the number of answers right 97.6% at the time. It's a benchmark of multiple tests. Whereas the June version was absolutely abysmal, right? These are mathematical tasks. It's not fancy logical reasoning or anything else, right? Very simple mathematical tasks. Code generation became significantly less reliable. Visual reasoning on images became a significant problem again, right? Between the earlier versions and the next version. And when the paper came out, when this came out in July 23, there was actually no response from OpenAI at that time, but there was a lot of Twitter chatter around that time. And so a lot of conjecture around what's happening. Eventually, OpenAI did multiple, you know, uh, um, you know, I would say information sharing about this, and the reasons were given as multiple reasons, not necessarily one reason. But the most important thing they clarified is the model degeneration in performance was not intended, right? They didn't intend for this behavior. Obviously, they acknowledged the behavior, but they didn't intend this behavior. They gave other reasons for what's possible, what might be happening. So one thing that could be happening is prompt routing, which means earlier this particular this particular type of engineered prompt was getting routed to a specific API within OpenAI's existing private infrastructure, but now it's getting routed to something else. Or the other reason could be that there is a load balancer running because ChatGPT was extremely popular. So the backend model was getting hit left, right, and center with very high concurrency, and obviously latency was always low, right, with ChatGPT. So they had a load balancer which would balance out the load across all the GPT model copies that were running. And one such, load balancing decision that was taken would be, might have been to route it to a smaller quantized model, not the actual GPT-4 model itself. You might ask, why did they do that, right? Because it's breaking a promise with respect to using a smaller variant which is less accurate, etc. That's a different question. But load balancing might have happened to a smaller variant. The third is there are rewriting engines or layers in between which would rewrite the prompt, and in doing so, made it less optimal in terms of performance and accuracy. We just saw, right, earlier in this lecture that a good performing prompt, it's best that it's templatized and it goes hand in hand with the backend foundation model, much like SQL to the database. So now if you have a layer which was introduced by the third-party hosted API provider, and that layer is rewriting the prompt, unto what end, right? Who's deciding on the accuracy? Who's deciding on the optimality of that? Significant questions there. And the last but not the least is they also mentioned that safety patches done for things like toxicity screening and things like that also ended up affecting the performance inadvertently. So if you see the reasons here, not all of it are related to LLMs at all. In fact, most of it is related to engineering. So this is one of the reasons why the predictability of the behavior goes for a toss with third-party hosted APIs, even for LLMs. Whereas if you host it yourself, you've got full control on these factors, on load balancing, on prompt rewriting, etc., etc. So third-party APIs are not static APIs. They keep evolving in the backend. You might not know about it as downstream consumers.